in this video we're going to talk about basically how we're going to do a lot of our analysis of the data we get in labs, right? So we're going to use what's called a percent error calculation, and it's going to tell us how far away our measurement and our data collected is from what we should have gotten, right? Now, a lot of times in lab, things go wrong. You know, ask any of your older friends that have already taken chemistry. A lot of times you get really crappy data from some chemistry labs. That's okay. We just need to have a way to talk about how bad or how good our data is, and we're going to do that with percent error. So I've put up the equation for percent error, and there's just a couple things I want you to take note of. So it is the difference between your experimental measurement, your experimental value, minus the accepted value, but that's in absolute value. So why would you think we would take the absolute value of this difference? We don't want negative numbers because we don't want a negative percent error. That's kind of meaningless. So we're always going to make our percentages positive, right? Because it's just how far away from that accepted value your measurement is. It doesn't matter if it's below or above that accepted value. We just want to know how far away it is from that accepted value. So we'll put it in absolute values, and then you're going to divide that difference by the accepted value. Now, if you just stopped right here, that would get you some sort of decimal, okay? But we want it in percent, so in order to go from a decimal to a percentage, we will just take this and multiply by 100%, okay? So let's just try a couple. Let's say you are, again, let's do the boiling water example I've used in the past. Let's say you get an experimental value of 87.3 degrees Celsius. So that will be our experimental. We know our accepted value for boiling water is 100 even. So we'll put that into our equation. Percent error equals the absolute value of 87.3 degrees Celsius minus 100 degrees Celsius all over 100 degrees Celsius, and then we'll multiply that by 100%. Now, you math savvy kids might notice, obviously in this example, these guys will cancel out because they're both 100. That doesn't happen that often, but if you do the difference, you'll get 12.7 there, divided by 100 will be 0.127, then multiply by 100, and you would again get 12.7% error. That is just saying that your answer, your measured value, is 12.7% away from what it should have been. Okay? Let's try a little trickier one. Let's say we're looking at someone else's lab report, and we don't know what they got as their experimental measurement. But we know that they got a percent error of, let's say, 8.70%, and the accepted value in this case should have been 85.0. Okay, we'll just say degrees Celsius again, just as an example. And I want to know, what must that experimental measurement have been in order to get an 8.70% error? Okay, so let's set up our percent error calculation, and we'll say the experimental value minus 85.0, all of that in absolute values, divided by 85.0 degrees Celsius. Notice it doesn't really matter if you keep the units along for the ride here because they'll always cancel out anyway. So don't worry too much about that. And then this is 8.70%. So take a second, see if you can, after we've set up the equation, see if you could solve for the experimental measurement in this scenario. Notice these absolute value signs, they're going to make it a little tricky, but hopefully you'll remember what to do from like, I don't know, 8th grade algebra. Okay, so we'll get rid of that 100%. We'll get rid of this 85. We'll do all of that multiplication and division. And so we will end up having the absolute value of the experimental minus 85.0 equals, let's get our calculator. And we get 7.395. Okay, and now it's a little tricky, right? Because this experimental value, because it's in absolute values, it's saying that this is how far away your measurement is from 85, but it could be higher than 85 or lower than 85. So we're going to have to do 2 quick calculations to figure out the possible experimental measurements based on this equation because it's in absolute values. So we could say that the experimental minus 85.0 equals 7.395, or we could say that the experimental minus 85.0 equals negative 7.395, and then you can just solve for 2 possible experimental measurements because you again don't know if that error corresponds to a measurement that's too high or too low, so you have to account for both. Okay, so you would just add 85 to both sides and you would get your 2 possible measurements. All right, that's it.